Appreciate the introduction, and thank you, New York Passive House, for having me for this presentation this afternoon. As Jose mentioned, I work for 475 High Performance Building Supply. See some familiar names in the audience, so I think some of you are familiar with what we do at 475, but for those of you that aren't, just to give a brief introduction, we are an e-commerce business supplying primarily European building materials to the United States and Canada to facilitate high-performance construction. I am a product consultant at 475, and I specialize in the LAMILUX Skylights that we supply from Germany. And in addition to being a product consultant at 475, I'm also an assistant adjunct lecturer at City College, where I work alongside Alan Barrows to teach the low energy buildings course. So as I mentioned, 475, we are trying to facilitate high performance construction. And when we talk about high performance construction, we're talking about high performance according to the Passive House principles. As we know, air tightness, insulation, thermal bridge free design, ventilation, and high performance fenestration. Today, we're going to be talking about specifically high performance fenestration, specifically fenestration at the roof, i.e. skylights, glass roofs, etc. How we can utilize them effectively in high performance design, and special considerations for really ensuring that we're getting the most out of our components. Because anytime we do put a hole in our envelope, whether it's for a window, a door, or for a skylight, we want to be ensuring that we are getting, one, a high performance component that provides excellent thermal protection and air tightness, and two, a very sound and robust integration with the thermal envelope and with the air control layer. A little background about 475. We got our start about 10 years ago, almost 10 years to the date, in Brooklyn, where COO Ken Levinson, CEO Flores were working on a passive house retrofit in Brooklyn, New York. You can see the building here on the left. They're having some trouble meeting the air tightness scores for this retrofit, and so they teamed up after the project to bring some materials that facilitate air tightness to the United States from Europe, from a company called Proclima. A few short years later, these products were utilized on the Cornell Tech Tower on Roosevelt Island, which at the time was the tallest certified passive house in North America. In addition to the passive house methods, we also like to think that we're reimagining the construction industry, trying to get away from materials with a higher embodied carbon, materials that potentially have more toxicity that can be harmful to tenants. We like to start the presentation with this comparison between someone installing spray foam on the left and then someone installing our Proclima materials on the right, just to kind of give a sense of the different properties of these materials. On the left, obviously, our installer is wearing a hazmat suit and a ventilator to ensure that they are protected from the materials they're installing. On the right, there's much less protective equipment required. So just kind of thinking about what materials we want to be using in our buildings, not only from a embodied carbon perspective, but also from a health and comfort perspective. As I mentioned, we're an e-commerce business, so our store is our website. We supply our components and materials to the US and Canada, and you can order materials through our website or get in touch through the same source. Currently, we have developed a series of ebooks and CAD details called the Smart Enclosure, which allows architects, building professionals to easily implement a lot of the materials and components that we supply into their designs. And we've always been looking to supply materials and components that sort of fill the hole in the market, kind of provide some of what we see the high performance market is missing. And today I'm going to be talking a little bit about one of the specific product groups related to roof daylighting. That's the LAMILUX Skylights and glass roof systems that we supply, as I mentioned earlier, from Ray Au in Germany. So where do we utilize roof daylighting? Well, anytime we utilize daylighting in general, we're getting certain benefits. Improved health and productivity are certainly among them. We know that students who have access to daylighting during tests perform better on tests. Shoppers in retail locations with access to daylighting spend more time shopping. Hospitals see improved performance through access to daylighting. There's a lot of benefits to providing access to natural light in our buildings. One of that is also aesthetics, right? There's a certain quality of light that comes along with daylight that we might not be able to replicate through electric light. And there's definitely architectural and aesthetic benefits to utilizing daylighting in any setting. Specifically for roof daylighting, there is a greater potential to reduce electric loads because of their location on the roof. Skylights and glass roofs can take advantage of more direct sunlight, more illumination, thereby providing greater reductions for the electric loads in the building. And similarly, whenever we have illumination from natural light, we also have solar heat gain. So we are also able to take advantage of greater internal gains through skylights, again, due to their greater amount of direct exposure to the sun throughout the year. Natural ventilation is a big one that's sort of unique for roof daylighting, or at least more effective at the roof because of the ability to exhaust stale air as it rises through our building, particularly in taller buildings, by taking advantage of the stack effect, or by, in the summer, opening skylights during the evening to allow that heat to sort of ventilate throughout the night. Exterior access, particularly relevant in urban settings, but skylights allow us to put a whole opening on a roof, which could be potentially serving a dual purpose of also, in addition to providing that natural light, also allowing for exterior access, thereby providing connection to the outdoors. So that's sort of a nice perk that's unique to roof daylighting as well. And then finally, energy positive potential. I'm not going to get into it too much in this presentation, but by utilizing skylights that provide excellent thermal protection and air tightness, as well as a high solar heat gain and a shading element, we can actually see in heating climates that skylights provide a net positive to our building energy performance throughout the year. So utilizing these things with different components to effectively provide daylight in all seasons. So kind of as I alluded to in the previous slide, due to skylights location on the roof, they get more direct sun. So if we're looking at illumination as measured in foot candles, we can see that the direct sun provides between 5,000 and 10,000 foot candles, typically on a typical sunny day. However, even on a dark, heavily cloudy day, we're still getting about 1,000 foot candles of illumination. Typically, office work requires between 30 and 100 foot candles of illumination. So we can see that even on a dark, heavily clouded day, there is potential for us to achieve enough illumination through skylights to significantly offset the requirements of our electrical lighting. For this reason, skylights can easily be 3 to 10 times smaller than a window while still collecting the same amount of light. So sort of when we think about our envelope and we think about opening that envelope to add a window or a skylight, as I mentioned earlier, we're talking about adding a weakness to the envelope, right? It's pretty rare that our window or our skylight is going to perform to the same thermal level that the envelope itself is performing. So we want to be thinking about whenever we open that envelope, how we can do so most effectively. And skylights are one way that we can do so because we can make that opening smaller and still get the same benefits in terms of illumination and solar heat gain. Just diving into that a little bit more, if we're looking at sort of this diagram on the right, we can see that in a space such as what we're seeing in the top image, the daylight from windows is somewhat limited, right? We're going to get illumination on the side of the room where the windows are installed. However, it might be darker at the interior of the space. As sort of a rule of thumb, we like to say that the illumination provided by a window is about 2 times the head height of that window. So in other words, the light from the window will penetrate into our interior space about 2 times the head height of that window. By adding a light shelf or a clear story, we can increase the penetration of that light through our window. Typically, we like to say that will increase the penetration to about 2.5 times the head height of the window. However, we can still see that we're getting uneven illumination, even though this clear story does provide benefits and can also allow us to achieve LEED credits. However, by utilizing skylights, evenly spaced and with splayed light wells, we can see that it's much easier, much simpler to evenly illuminate the space without any particularly dark spots. And this is more achievable for buildings that, say, are not able to provide windows on all sides of the space. However, despite their benefits, there are also common problems associated with roof daylighting that sometimes make them an unpopular choice among building professionals due to past experiences or negative client feedback. Because they are positioned at the roof and they do get so much more illumination and heat, they are also potentially allowing for glare and summer overheating, right? Because we are getting so much direct light that can provide issues with visual comfort or with thermal comfort and energy use. So definitely thinking about how we're going to moderate those factors when specifying our glazing, and then also thinking about utilizing shading to prevent some of those negative effects. In addition, because again, they're positioned on the roof, skylights are particularly susceptible for winter heat losses. So when we are heating our interiors during the cold season, that heat will rise, and potentially, if our skylight is not providing excellent thermal protection and air tightness, that heat will dissipate, whether through conduction or convection, through our roof and lead to increased heating requirements. I'm sure many of you guys, like myself, are based in New York or a similar urban setting. Many of our multifamily buildings have these old skylights, these wire frames, sort of aluminum skylights that actually are designed to ventilate. And so instead of providing thermal protection, they just allow heat to blow right out of the skylight opening, thereby also ensuring that the skylights are ventilated and protecting against my next point, condensation. Which can occur particularly for skylights that do not provide thermal protection, right, that aren't thermally broken. We can see, particularly during the cooling season when it's very hot, very humid outside, that there is contact between our hot, humid air and our cold, dry air and our air conditioned interior, which can lead to condensation at the interior. You may complaints from your clients talking about how their skylight is leaking, how it needs to be replaced, or even how their new skylight is already leaking. In many cases, it's not the skylight leaking, it's just condensation occurring because that dew point is not being isolated at the exterior. So talking a little bit more about these comfort drivers, this is a pretty common sight in New York City, a building made primarily of glass in the envelope. And what we can see here is that despite the fact that this building was designed to take advantage of the tremendous views, many of these tenants have chosen to draw their shades. So despite the fact that we've greatly weakened the envelope of this building by using all of this glazing surface area, we're not even getting the full benefit in terms of illumination, in terms of solar heat gain, and in terms of views that we were striving for, because we did not consider the effects of flare and overheating. This sort of design can be greatly improved thermally by simply breaking up the glazing at the floors and the ceilings at each story, which would prevent a significant amount of thermal bridging and while not really having to compromise the views or benefits of the glazing. Another example here of our comfort drivers, when we have glazing components that are not thermally broken, we can see conduction occurring, right? Heat transfer occurring through those glazing components, whether it's a window or a skylight. And this heat transfer can actually lead to sort of a radiant heating effect. It could almost even feel like a radiator has been left on when these surfaces at the interior get too warm. So we have heat transfer during the warm season, during the cooling season, from exterior to interior, and the interior glazing surface and frames actually get so warm with the interior that it leads to a feeling of discomfort and a feeling of thermal asymmetry. Taking a little bit of a closer look at that, you can see the images here in the bottom left, which illustrate on the left a home with a low performance window and a home with a high performance window. Because of the cold night outside of the home in both examples, there is that cold air can dissipate to the interior, and it can lead to the interior surfaces of our window becoming quite cold, much colder than the interior air temperature of the space that we're in, which can lead to feelings of thermal asymmetry and discomfort. It can maybe even feel like the space is drafty, even if that's not the case. What we often see is done to mitigate this, particularly in older buildings, is that if you look under your windows, you'll often see that's where the radiator is located. And the radiator in those instances is essentially working to offset the effects of thermal asymmetry, not by providing thermal protection, but just by providing more hot air than the cold surface can overcome. On the right, if we improve the glazing component in our assembly, we can see that interior surface temperature of our window is much closer to the interior air temperature. And for that reason, we're going to experience greater comfort. In addition to uniform surface temperatures, you also want to be thinking about uniform light distribution, which can enhance visual comfort and the sort of interior environment in general. So many skylights do not really intend to prevent thermal bridging at all. In fact, many skylights are designed with the expectation that thermal bridging will occur. And with that expectation in mind, they actually design those skylights with an interior gutter. And this gutter is meant to collect any moisture at the interior that occurs due to condensation, which the manufacturer in most cases sees as inevitable. And this moisture often is whipped to the exterior through a weep hole that penetrates through the skylight's airtight layer. This is obviously not a suitable solution for high performance or passive house construction for a number of reasons. The thermal bridge is concerning, and the condensation that occurs because of that thermal bridging is also problematic. And in addition, obviously, having a weep hole in our skylight is going to lead to issues with our air control layer. So this sort of solution that utilizes an interior gutter and the weep hole is something that we want to look to eliminate as much as possible, and something that we need to eliminate entirely if we're going to be utilizing skylights in a passive house design. LAMILUX, which is the product group that I consult on, addresses a lot of these comfort drivers through a number of performance-based features. The skylights virtually eliminate the risk of condensation because they are thermally continuous. This means that there is no interior gutter or weep hole required, which also means greater air tightness for the skylights. Similarly, they provide best-in-class energy performance, that's thermal protection and air tightness. You're getting really high-quality daylight through the glazing surface. So you're going to get excellent illumination and solar heat gain. However, we can also specify specific glazing to ensure that that solar heat gain and visual transmittance is mitigated as needed for energy performance and visual and thermal comfort. Added comfort for those same reasons, because we have thermal protection, because we have air tightness, we're not going to see heat loss, heat transfer through convection. We're not going to have those feelings of draftiness or thermal asymmetry, as we know is typically the case for passive house. And similarly, sound insulation, we're talking about the benefits here of a high performance envelope. Skylights being part of that envelope are going to add to the overall effectiveness of the sound protection at the interior. When we're thinking about skylights, or really any glazing element, whether it's a window, glass door, or curtain wall, we're thinking about the U value or the R value for that component. We want to remember that the U value for the entire component is a weighted average of its individual parts. So in this case, we're looking at a continuous roof light. It has some sort of polycarbonate glazing surface with aluminum frame. And obviously, with all these different materials being used, we need to understand the U value for each of these materials and the total surface area as a percent of the overall surface area that each of these materials represents. So we're not looking at just the U value of the glazing, but also the U value of the various frames and even the hardware that is used to assemble the skylight. So we want to be thinking about, one, the glass. That's sort of pretty obvious. We're thinking about high performance fenestration and passive house. We know it has to be triple glazed. We know that it has to have noble gas in the air gaps, and we know that it has to have a super spacer at the edge. So we want to make sure that we're getting those IGUs at our skylights as well, that they have that triple layer insulated glazing, and they have a warm edge spacer, which is going to prevent thermal bridging around the glass, between the glass and the frame. Surrounding that spacer, we want to make sure we have an optimized impermeable core, so insulated frame essentially that's going to prevent any thermal bridging from occurring through the skylight profile. That's the key component for preventing condensation and allowing us to get away with a design free of any sort of gutter. We want to make sure that we're getting an airtight design. So our connection from the skylight to whatever curb we're using, whether it's the manufacturer's curb or a site-built curb, needs to be airtight. This LAMILUX skylight provides 3 layers of gaskets to ensure that airtight connection. And then the skylight is also available with an insulated curb in a variety of heights to ensure that you're getting a continuous thermal connection with the existing structure. And that continuous thermal connection is really so key. Even if we are specifying a high performance skylight window or door, if it's not installed properly, we can see significant detriment to the overall performance of that components. So just a quick example here, looking at a window. If we're thinking about our window's placement in the overall wall assembly, we want to be aligning that window, which is going to be our thermal control layer at the opening, with our insulation in the wall, which is of course our thermal control layer for the assembly. So if we have our window located at the exterior, as we can see in this image on the left, what we'll see is thermal bridging occurring. Our isotherms in this thermal model are kinking out. We're getting some cutting of this corner here, which can lead to thermal bridging, physical discomfort, as well as potential condensation, which can be quite problematic. In addition, in general, we don't want to be installing our windows at the exterior of our envelope because it makes them very vulnerable to bulk water. Similarly, if we install our window at the interior, we can see, again, thermal bridging occurring around the frames. We can have some of those same problems occurring at the interior. What we really want to be doing is what we see here in this middle image wherever possible, and that is integrating our thermal control layer at the window with our thermal control layer in the wall, ensuring that we're getting our nice straight isotherms, indicating minimal thermal bridging, condensation, and maximum thermal comfort. And so we want to be thinking about these same principles when we are integrating a skylight into our roof assembly. Skylights that are supplied with the integrated curb from the manufacturer, such as LAMILUX skylights, are ideally suited for this integration because the integrated curb allows you to sort of plug and play the skylight into your roof assembly and run the insulation of your roof into the side of the curb, thereby creating a thermally continuous connection between the roof assembly and the skylight. So that sort of component is really useful for ensuring thermal continuity of the envelope at the roof. Looking at the same sort of installation in a thermal diagram, we can see that although I've created an opening here for a skylight because it is a high performance component. We are seeing minimal thermal bridging from the connection of the roof assembly to the connection at the curb. So we're getting nice straight isotherms, and our dew point is remaining at the exterior. So we're not going to see any condensation. There is some, as you can see, slight thermal bridging occurring through the profile here. Not enough to create condensation, but that is enough to eliminate this sort of LAMILUX FE solution from being a passive house certified component. However, as I'll get into in a few slides, there is also a passive house certified component available through LAMILUX. So again, thinking about optimizing installed value. So we have our triple glass, our insulated curb, our insulated frame. We know our skylight is thermally continuous, and then ensuring that that curb meets the roof insulation so that we have no thermal bridges and over insulated foot. Similarly, if we can't utilize a manufacturer's curb, we can also get high performance through a site-built curb. This is, again, a LAMILUX skylight. Instead of being installed on a prefabricated curb from the manufacturer, this skylight is actually been manufactured in a custom size, so we can't supply it in that case with a curb. We have to supply it for a conversion adapter with attachment to a site-built curb. So what you can see here is it has this sort of drip edge, sort of flange element that goes down on the curb, and then the skylight attaches to that flange element using pins, and this allows us just to provide greater variety of sizes for these units. And then similarly, we can see here, we're looking at another thermal bridge model, like thermal diagram. So we can see we have our isotherms flowing from our roof assembly through our curb, which in this case is an insulated cavity, insulated with cellulose, into our skylight profile, and then our glazing. So once we get from the curb, from the roof to the curb to the skylight, we know that we have created a thermally continuous connection, and that we're going to be able to prevent thermal bridging and condensation from occurring. Just want to give a shout out to Building Type, passive house modelers and consultants that helped us with this thermal bridge model. The LAMILUX skylights that we supply, we do separate into three product categories. I think most relevant for this presentation are the roof glazing systems and the flat roof unit skylights, which I'll talk about a little bit now on the next few slides. We also can supply roof access solutions, but I'm not going to get into that as much here on this presentation. Before I get into this next section, are there any questions?
Yes, I do have a comment from Laura Blau, and her
Hello.
comment is, the roof is at least twice as insulated as the walls, so the proportional loss would be different than a wall window, wouldn't it?
Yeah, it's an excellent point. And I think for that reason, anytime we're creating an opening in our roof, it's even more critical that we're utilizing a high performance component. But as mentioned earlier in the presentation, one of the disadvantages to utilizing skylights or glass roofs is that they do create weakness in our envelope at the roof, which leads to greater heat loss potentially throughout the year due to the tendency of heat to rise and be transferred through these openings. But that is a good point. Thank you.
That's the only question for now. I do have a question. If you were to add some window treatment or shades, is that going to also kind of trap the heat above when you have the sun shining in and help with the condensation, or is it going to be a better, let's say, buffer in case you have a warmer or cooler interior space in relation with the outside temperature?
Definitely. So I'm going to talk a little bit about the shading accessories that we have available. We're talking about passive house. Obviously, we want to be thinking about shading at the exterior whenever possible, because that's going to prevent that solar heat gain that from the sun, that radiation from ever entering our interior space. If we have shading utilized instead at the interior, what we might see is convective loops being created, which can lead to feelings of thermal discomfort, thermal asymmetry, and draftiness. However, interior shading, I would still say, is better than no shading for climates that are going to have prolonged cooling season. Typically, the insulative benefits of shades are minimal, so you're not going to really see any effective shades, any significant effect of shades on the U value of the component or the U value of the glazing. But the benefits are really in preventing, or I guess mitigating, the radiation. So there won't be so many, they won't really affect the potential for condensation, but it will affect, I guess, the overall energy performance of the building throughout the year.
Thank you. And one last question from Jane Sanders.
Mm-hmm. Hey,
Does
Jay.
LAMILUX make a walkable skylight?
LAMILUX does not make walkable skylights. The skylights I'm going to talk about today are walkable for maintenance purposes and cleaning, but they're not intended to be walkable sort of at a roof deck. We do also work with a company called Facro to supply pitch-through skylights. Jane, you might be familiar with those solutions. Facro can supply a walkable high-performance skylight for use at a roof deck in sizes up to about 4 foot by 4 foot. So sort of a similar solution, but with walkable glass that sort of has a print over it that ensures that there's no or low risk of slipping. So the first product group I want to talk about are the unit skylights, the LAMILUX FE or the glass skylight F. You can see the profile for the skylight here on the right. It's essentially the skylight profile that I've been showing on many of the previous slides, but you can see for that reason it has sort of these high performance components that I mentioned previously, i.e. the insulated core, preventing thermal bridging through the profile, our insulated glazing with a warm edge spacer, and aluminum drip edge over our dual areas or dual gaskets, ensuring protected air tightness. And we can see from our thermal model that this assembly does provide exceptional thermal protection and continuity. So it is suitable in many cases for pass-house certification, depending on your climate, even though it is not a pass-house certified component due to the small thermal bridge through our insulation layers. It's a pre-assembled solution. So what you see here is what you get. You can order the skylight in a standard size, in which case it comes on an 8-inch, 12-inch, 16-inch, or 20-inch insulated curb. Skies are also available in custom size, as mentioned previously, in which case they're delivered with a conversion adapter for attachment to a site-built curb. Triple pane insulated glazing is available with a UG value as low as about 0.11. So again, suitable for passive house construction and certification in many climates. Thermal bridge free profile, not entirely accurate. As I mentioned, we do have that small thermal bridge between our two insulation layers. However, for the most part, it is thermal bridge free. There's zero risk or virtually no risk of condensation. Insulated curb, as I mentioned, is available in a variety of heights for different roof depths. And that the insulated curb is ideally suited to create that thermally continuous connection with the roof assembly. PHC certified component. And actually, I'm sorry, this is incorrect. It's not a PHC certified component. This is, in this case, the FE is not a certified component. It's pass house compliant. It can be used on many projects, but it's not certified. Sorry about that. And as I mentioned, custom size is available without the insulated curb. Intended for low pitch applications up to about 25 degrees. In addition to the FE skylight, we also have the FE pass-fail skylight, which is our pass-fail certified component. So it provides superior thermal performance through added insulation at the profile and an improved UG value. Again, it's pre-assembled. This solution is only available on an insulated curb in limited sizes. It cannot be installed in custom sizes with an adapter for attachment to a site-built curb. That integration with the curb is critical for the pass-fail certification of the component. Again, triple pane insulated glazing, but as you can see, the U value is slightly improved to about 0.09. Thermal bridge free frame, again, through this added insulation, you can see there's not that thermal bridge we saw previously occurring through our insulation layer, so entirely thermally broken. Again, the insulated curb available in this case with a height of 16 or 20 inches. And again, intended for low pitch roof applications up to about 25 degrees. And this is a PHA certified component, as I mentioned, the highest available efficiency class. In addition, they can also supply the skylight with quadruple glazing, quadruple layer insulated glazing, which is really only suitable for the coldest of climates, but is something that we can supply for unique projects. We found that the FE skylight is tested in accordance with American and Canadian standards for air and water tightness, and it provides fall-proof and fire protection according to these standards. The FE Skylights, LAMILUX's slogan is customized intelligence, so there's certainly no shortage of custom options and solutions. The FE can be customized in a variety of shapes and, as I mentioned, sizes. So in addition to the traditional FE 0 degree unit skylight I showed previously, we can also supply that same skylight with a 3-degree integrated curb to shed bulk water in flat roof applications. We can supply it as a circular skylight with the same thermally continuous and airtight assembly, or a hipped pyramid skylight for a variety of applications, specifically maybe trying to match the aesthetic of a typical New York City ridged or hip skylight. In addition, the FE passive house, which is a certified component I mentioned on my previous slide. And then we also can supply the FE exit hatch, which is the skylight equipped with pistons for roof access, typically over a ladder. As I mentioned, a key advantage to roof daylighting in particular is ventilation, due to the ability for us to take advantage of the stack effect, and also for summer exhaust of heat during the cooling season. The FE skies can be equipped with a variety of different ventilation accessories to take advantage of this benefit. The manual spindle available for smaller skylight sizes, shown in the top left, a concealed chain drive or a curb mounting chain drive, the option shown here on the right, for motorized ventilation, even for the largest of skylight sizes, and then the spindle motor, which is another alternative motorized solution, again, allowing for motorized venting of the skylight. In addition, as I mentioned, shading definitely key for mitigating solar heat gain and visual transmittance in the cooling season. LAMILUX skylights can be supplied with interior or exterior shading, as well as exterior fixed shading. So a variety of options there as well. In addition, a variety of glass types available with different solar heat gains, different visual transmittances, and we can even supply fretted glass for sort of a fixed shading benefit. Looking at a few product examples, here's a project in Brooklyn that utilized an FE. This was a standard sized FE, meaning it was supplied with an insulated curb. You can see in the images on the left, the exterior and interior of that LAMILUX skylight. This aluminum profile can be powder coated in any raw color. In this case, they just chose the cold aluminum finish, which is sort of the standard finish. And at the interior, the skylight was supplied with the insulated curb, which always has this smooth white coat at the interior. On the image on the right, you can see the roof flashing riding up the side of our insulated curb, and then being terminated right below our drip edge via this termination bar. So a nice simple plug and play installation. In the background, you can see our FE exit hatch, which is the smaller skylight. In this case, that skylight has pneumatic pistons, allowing for roof access via a lockable latch. Another project here, this one featured the FE 3 degree. This is the old generation of the FE 3 degree. This skylight now features a nice chamfered edge and concealed screws at the frame. But this is a bit of an older project, again, in Brooklyn, being air sealed and installed by our friends at Brennan & Brennan. Nice sort of walkthrough of the basic installation principles here, which I think are important to highlight. Looking at the image in the middle, you can see that these skylights have been, installed on a platform. So they kind of sit above the roof level, and then they have this insulated curb, which elevates them further. At the base of that curb, you can see a foot flange, which we've fastened through to the substrate below. That's sort of our mechanical connection to the roof. What's going to happen next is that the roofer is going to run his insulation into the side of that platform, into the side of the skylight curb, and he's going to create that thermal connection that we looked at earlier by over-insulating the footing of this curb. Then he can run his flashing up the side of the curb over the installation, as we saw on the previous slide. Looking at these images on the left and the right at the interior, some really nice details going on here as well. You can see that the curb has been taped to the interior buck using our Contiga Solido SL tape, which will also allow them to plaster up to the interior of the curb. You can see that the skylight opening has been framed such that it is slightly wider than the curb bottom opening dimension, which is then going to allow them to ensure that that plaster sits flush with the interior of the curb. In addition, they've utilized the 3D skylights because, as I mentioned, that integrated 3-degree pitch is going to shed bulk water and snow throughout the year effectively. Another project example, this one is a Barry Price project in New York, featuring 2 of our Pass certified skylights. You can see they feature a nice RAL coat at the exterior. As I mentioned, you can do any color for that profile. These skylights are utilized over a stairwell on either side of the roof ridge. Again, a low pitch application. I really like this image on the bottom right because it's been installed. These skylights have been installed on a metal roof, and you can see that copper flashing sort of wrapping up underneath our drip edge, creating a nice continuous aesthetic, even though the skylights, again, were supplied with that insulated curb. Oh, and this was a Pass certified residence, as was this project, a Pass certified daycare in Vancouver, which utilized several of these Pass certified skylights over the daycare space. Don't have any finished photos yet, unfortunately, but hoping to get those soon. You can see again that the skylight was elevated over the roof using this platform and then this insulated curb. So again, we can have our insulation, even though it's a passive house project, but we'll have a thicker layer of insulation at the roof. We'll still be able to integrate our skylight effectively. In addition, you can see these certified skylights featured an interior spindle opener, which will allow those skylights open for venting purposes. So in addition to the unit skylights that we supply, the LAMILUX FE and alternatives, we also supply the PR60 roof glazing system through LAMILUX. The PR60 is essentially a curtain wall for the roof, what we call a glass roof system. And so it's made up of a kit of parts that come together to, again, provide a thermally continuous and airtight construction, ideally suited for more complex, more custom, or maybe even larger glazing roof daylighting elements in different project types. You can see this skylight also features a thermally broken assembly as per our isotherm diagram on the right, with a insulated, impermeable insulated core, which I'll show here in a second, as well as that triple layer insulated glazing again with warm edge spacer. So it's a multi-unit transom system. So again, as I mentioned, it's assembled from a kit of parts, which includes double or triple layer insulated glazing units with an exceptionally low U value, thermally broken aluminum profiles, and then insulated flashing connections to the existing structure. It's fully customizable, offering unparalleled degrees of design flexibility with installations possible from 2 to 90 degrees. So it can be a horizontal glazing surface. It can also include glass gables that might come down vertically to the roof assembly. Glass gables can be created to be quite large, up to about 6 feet square, 10 foot by 3 foot. And we offer a variety of services in support of these PR60 systems, which are a more technical system, and I'll get into that here in the next few slides. The PR60 is a structural glass roof system, meaning that it is self-spanning. So up to spans of about 20 feet, there's no supplementary structural support required. And we can even get a little bit, we can even have be self-spanning over larger spans, potentially through steel reinforcement supplied by LAMILUX. Excuse me. The visible width of the skylight profiles is 2 3/8 inch, 60 millimeters. That's where the name comes from, PR60. And the height of the profiles varies from about 2 3/8 inch up to about 8.5 inches, depending on the static load. Looking at the breakdown of this PR60 system, this is sort of the different components that I was mentioning a couple of slides ago. We can see from the interior to the exterior, we have these narrow support profiles, 60 millimeters or 2 3/8 inch wide. So you're really getting great sight lines. We have a multi-stage seal system at the interior. So the PR60 is a dry glazed system. There's little to no silicone required to seal the system or to glaze the system. So we have gaskets at the interior and the exterior, and that is going to ensure that we have excellent air and water tightness. In addition, this PR60 features a patented multi-stage seal system with secondary water drainage. A little bit difficult to describe using this image, but what we can see is that the connection between this glass and this gasket occurs right here at the outer edge of our profile. At the inner edge is actually a small channel, which is outside of our airtight layer, but can collect any condensation that might occur and ensure that condensation is ventilated to the exterior without penetrating our airtight envelope. Exterior of that gasket, we have this sort of mounting component. You can see a sort of M-shaped bracket here, which is made of UPVC. It's a thermally broken material, which holds our optimized insulation core. This is just a strip of foam insulation that's going to prevent the majority of heat transfer from occurring through our profiles. We have a secondary gasket at the exterior, which is going to ensure that we have an additional level of air and water protection. And then we fasten these components through the profile through this clamping strip, and the actual pressure of that clamping strip is what's going to hold this system together and provide that water seal. In addition, we can provide these cover strips to provide a different aesthetic. To talking about some of those services I mentioned that we supply in support of PR60s, 475 is able to assist with design development and shop drawings for every PR60 system. Here you can see a shop drawing of a PR60's connection to a site-built curb. A few things going on here. Here is our skylight profile that we just looked at and our connection to our triple layer insulated glazing. You can see that profile is insulated at the eaves. with a foam insulation under the flashing cap. And then again, the profile insulated at the exterior with mineral wool also supplied by the contract or by the manufacturer. What's nice about the PR60 system is that you can design your curb, ensure that it's it has adequate insulation and air tightness. You can finish that curb, and then our PR60 will come and we will supply everything above that curb, including connections to that curb. And that means that we are engineering the thermal connections and the airtight connections from the skylight to the profile, and so that we can really ensure that these skylights are integrated effectively for high performance. In addition, I forgot to mention this previously, but the PR60 is also available as a certified component with very small differences between the certified and uncertified solutions. So in addition to those design development and shop drawing services, we also supply obviously delivery, bringing these guys over from Germany to the job site, and then also installation support either via installation representation, where we work with the contractor, or in some cases, we can even bring on a subcontractor to provide full technical assembly and install, since these systems do require more expertise. As I mentioned, they offer unparalleled degrees of design flexibility. So there are a variety of options, shapes, sizes available. You can see a few of them here. Everything from pyramids to ridge roofs to barrel roofs and extremely large glass roofs are suitable for this PR60 system. And the PR60 is going to be able to offer that same degree of performance for regardless of design. Looking at some accessories here, PR60 is also able to be made operable for ventilation or smoke and heat exhaust via motorized openers. It can also be customized for roof access via pneumatic pistons, as shown here on the left, for manual roof openings, typically over a ladder, or motorized roof openings via sliding glass field or hinge glass field for roof access over a stair. And then again, shading critical, the same sort of shading options were available for the FV are also available for the PR60, interior or exterior motorized solutions, fritted glass or fixed exterior shading for constant light and heat mitigation. Ramping up here with a few examples from various PR60 projects. As I mentioned, we supply to the US and Canada. This project is in Toronto. It features 2 PR60s installed on either side of this interior partition wall. I think this project does a really nice job of showing how flexible the PR60 is in terms of how it integrates with the existing structure. Here you can see that we have a copper finish, which is installed pretty seamlessly around the curb. Not really any difficulty there integrating the skylight with that material. In addition, our skylight comes over top this interior partition roof with an aluminum flashing cap, which provides nice finish and nice seamless integration there. Another project, this one in residential BC, not really too much to highlight here, but just sort of a nice alternative design, again, demonstrating the flexibility of the system. Another ridge skylight, this one over a custom home in Minnesota. Here you can see the skylight was installed over a timber frame construction with the aluminum profile sort of set back to sort of conceal them. In Brooklyn, New York, this is one of the larger projects we've done, a very large glass roof with extremely large glass fields. This project featured a low pitch glass roof at about 5 degrees, and then also the vertical glazing surface, the curtain wall with integrated ventilation flap. Project in Manhattan, again, as I mentioned, we can do 2 to 9 degrees, so the sort of glass roof plus gable approach is also possible to this PR60 system. This project featured multiple ventilator flaps, as you can see, motorized openers. And looking at some passive house projects, this was a PR60 passive house, so a PHI certified component that we supplied for a project in the Bronx. Paul Castrucci designed the Woodlawn Senior Center, which is going to become one of the first passive house certified projects of its type. This PR60 was utilized at the ground level over a sort of interior below grade space to bring in daylight over an entry. It was a trapezoid shape with some particularly large glass fields. And as I mentioned previously, LAMILUX engineered the thermal and air connections to the existing structure to ensure that this passive house certified component will provide passive house levels of performance. A smaller project, also passive house certified, just again showing the flexibility of the PR60 system, which is available in all shapes and sizes. This is a pretty simple ridge skylight elevated slightly above the structure. only 2 glass fields, relatively little surface area, but they needed that pass fail certified component, and they needed the flexibility in design, so they opted for the PR60 system here. This guy also featured fritted glass to provide constant heat and light mitigation throughout the year. So thanks so much, guys, for sitting through my presentation here. And thanks again, Jose and Andreas of the Passive House for having me. Really appreciate it. It's been fun. I'll stick around for any questions if you guys have any, and feel free to get in touch via the means here.
Thank you, Jeremy. Really nice and interesting presentation on Skylights. If anyone has any questions, we'll be up and running until around, like I said, 1. So, you know, feel free to stick around and ask any questions you may have for Jeremy.
Happy to chat.
What's that?
I'm happy to chat.
Yeah. On my part, I think, yeah, you answered a question that Laura had about, you know, roof access to skylights. And also, I guess, tying into that question would be, you mentioned that you do services on detailing, right? And installation for architects, of whomever is trying to get them to their project, right?
Absolutely. Yeah. I mean, particularly for passive house design, we all know how critical it is to be working with your suppliers at a very early stage to ensure that you're getting the information and the tools you need to integrate those components into your design, typically before you even get into modeling. So we're definitely happy to support that process, provide drawings, calculations, whatever's needed in terms of design development and technical support, so that everything can be specified before the project even goes out to bid.
And on that question too, and my knowledge, and this is going to be very practical right now, not very technical, but if anybody is trying to get a skylight for their, let's say, speaking in New York City terms, you know, for brownstone or let's say for a smaller project, what's the process, and what do you think would be the best value for the performance and the money? Obviously, because I'm assuming you're not going to get, it's not like a window package that you get 10 or 15 or 20 windows. You may want to get 1 or 2 skylights, and I'm sure there's logistics and things like that involved. So I wonder, what's your recommendation when thinking about using high performance skylights for it to be obviously economically viable for the client? You know what I mean?
Absolutely. Yeah, obviously that's always a challenge. One of the biggest cost premiums for passive house is often the windows, particularly in the US, where most of the manufacturers are not located. So I think the challenges also exist for LAMILUX skylights. We do stock the LAMILUX skylights in 3 separate sizes in our warehouse in New Jersey, as well as exit hatches from LAMILUX in 2 separate sizes. We bring those skylights over in stacks of 4, which is just efficient from a shipping perspective. So we can offer cost-effective pricing on those units. We try and stock sizes that are common in the New York City, particularly residential market. We have 29 by 29 inch and 29 by 41 inch skylights in that inventory, which we see are particularly common for these sort of retrofits. So I think, yeah, in terms of cost effectiveness, those stock options are going to be your best option from LAMILUX. And then we can also sort of customize those stock solutions to a certain extent, providing ventilation, insect screens, different sort of accessories like that.
Yeah, and I think that's very important for everyone, at least on the design perspective, just to make sure that they have all the tools to discuss with their client and provide a design that is going to work in both, you know, interior design, because you get all the good lighting, as you were mentioning in the previous slides, from the horizontal unit on the roof. And also to make sure that you can reach these things if you have to at some point service them, right? On that note, you can source all the accessories, you know, like the insect screens and shades or window treatments, let's say, and hand cranks and things like that, so people can open and close them. So yeah, I think that, I mean, I think that's a great product that you can definitely take advantage of, especially in these apartments where you don't get that much light through the windows and in between the buildings. Yeah.
Absolutely, yeah.
And
I think that particularly in New
yeah,
York City construction, you see the skylight openings that we do have typically have these very old solutions, these components that are not at all airtight or thermally broken. So the effects of replacing those units, particularly with a high performance solution, can be substantial. I think there's really, in most cases, not a need to utilize the Pass-Fail certified components in our climate. So you can utilize the typical FE, and for projects that aren't going for certification at all, the double layer insulated glazing with the FE also always offers a lower cost and still with a U value of about 0.19, pretty effective thermal performance. So there are options there, I'd say, for most homeowners.
yeah, it's very good. 0.19 BTUs, right? The
Correct. Yeah, and
thermal
that's our
performance.
double layer glazing, so we can do quite much better than that if needed.
Yeah. And the other question tied into that is, so you could treat the glazing to whatever low E coating. Let's say somebody wants less infrared radiation coming in, or they want to get less heat gain for whatever reason, or they want to have more heat gain but without looking up and seeing a blue or green sky. Is that something that you can facilitate when discussing with your manufacturer?
Yeah, so the glazing from LAMILUX for these guides is available with a variety of different solar heat gains and visual transmittances. So we can get the right quality of light that you need, as well as the necessary performance specifications, solar heat gain and visual transmittance. And we're pretty flexible in that regard, so we can get the glass to be relatively clear. Obviously, at the roof, you need to be careful when specifying glass that is, say, ultra clear or low iron, because you are getting so much direct sun exposure. And if you're not mitigating that solar heat gain and glare, you can really have significant detriment, I would say, to interior comfort. So typically we are going to want to see some sort of low E coating, some sort of solar protection on the glass. What's nice about skylights in particular is that you're looking typically up at the sky, and there's not much to compare the color of the sky to in your sight line. So it's not as easy to identify say a blue tint or a green tint as you would be with a window, particularly with a window that you can open, where you can really see the comparison between the clear view and then the glazing view. So for skylights in particular, as you can see, for example, in this image, they do have sort of a, excuse me, a blue tint that's pretty apparent from the exterior. And I'll jump back a few slides here just to show this image as well. Here in particular, you can see at an angle when the light hits the skylight, it is sort of a blue hue. But at the interior, looking up at the sky, it's really difficult to tell if there's any color change at all, because your view is pretty monotonous.
Yeah. Yeah, I'm not thinking that's a big issue for many people. I'm just kind of, what came to my mind at that point is something that I've, at least for a couple of projects that I discussed before, that was a question that I got, and I really didn't think about it too much, thinking, the sky is blue and maybe you're not going to notice it. But I guess it's, the same thing you're just saying now, which I feel good about that.
Yeah, no, it's certainly relevant, particularly for pass-fails, obviously. But in terms of aesthetics, it's not quite as obvious, or even for that reason as important, I would say, as with Windows. And I am available by phone or email. So if you guys have any questions that come up later, or if you have any projects you want to talk about, feel free to reach out. I'm definitely happy to support.
Yeah, so I think it's 3 minutes to 1 p.m. I guess everyone can just have a little bit more time for lunch, and we'll see you on the next one. Thank you, Jeremy. Yeah, so guys, everyone, thank you, and we'll see you on the next one.
Thanks, Jeremy.
Thanks, everyone. Have a good day.